got 15 more minutes.
Do you agree with all of these parts? In between your neutral axis, we have tensile force T in the bottom reinforcement. We have compressive force, one in concrete, one in steel in compression. We apply equilibrium equation, so compressive force above your neutral axis equal tensile force below the neutral axis. From this equilibrium equation, I can figure out what is the value of distance A, depth of the compressive block. And from A, I can figure out what is the distance or what is the depth of your neutral axis. Do you agree? After this step, your cross section can be divided to two parts. This point is important. The first part between compressive reinforcement and tension reinforcement, both of them must equal. Your compressive reinforcement equal 2 inch square. That means this part must be 2 inch square. Plus, second part, your concrete cross section, plus remaining reinforcement here. Remember, if you add this part plus this part, you have to get the whole cross section. So 2 plus 0 equal 2. Okay. 2 plus what? Equal 6.25. So this value must be 4.25 inches square. Okay? Let's talk about the first part. For the first part, I know we have compression reinforcement, compressive force here, C. We have T1. The distance in between equal D minus A divided 2. So your nominal moment from the first part equal area steel 1 time yielding stress time your distance D minus A divided 2. I can get nominal moment only from this part. Second part, we have compressive force in this one, we have tension force in this one, the distance in between D minus D prime. Okay, so area steel time F yield, whatever area steel 2, or you can say area steel prime, both of them the same value. Time your distance, you can get your nominal moment. But from the second part, the total nominal moment for the whole cross section, add Mn1 plus Mn2. To get your design moment, multiply this value by phi, which equal 0.9. That's right? So far, we are good. But you did your calculations based on assumption. At the beginning, you assume your compression, reinforcement, or your steel reinforcement and compression yields. I would like to check this assumption. So check if steel or if compression steel yields or not. Okay, how I need to calculate the strain in this steel reinforcement, this value. We have two triangles. First triangle, the biggest one, something looks like this. Epsilon Cu equal 0.003. Here is your neutral axis, remember. This distance equal C equal 8.4. That's right. The second triangle, smaller than this one, like this. Epsilon C, epsilon S prime. This little triangle. Do you agree? This distance will be C, the total one, minus D prime. So 8.4 minus 2.5. Do you agree? So this triangle similar to this triangle. What is the meaning of triangle similarity? Means this term divides this term equal this term divides this term. Do you agree? I can calculate epsilon equal 0.0021. This value can be called compressive strain in area steel prime, in steel, in compression steel. What is the value of epsilon yield? Epsilon yield equal F yield divide E steel. If you go back to your stress strain curve, this slope of this relationship called E steel. E steel equal slope means the opposite F divided by the adjacent epsilon. So stress divide strain can give you the Young's modulus. If you need strain equal your stress divide Young's modulus. So your stress is yielding stress 60. Modulus of elasticity 29,000. Your value 0.00206, something like this. Make a comparison between this strain and the yielding strain. This value equal or greater than yielding stress, that means yielding happen. So epsilon steel prime greater than epsilon yield, so yielding occurs in area steel prime. So your assumption is correct. Compression steel yields. So all of this calculation is correct. What will happen if epsilon steel prime smaller than epsilon yield? These calculations are not correct. We need to do another calculation. You got what I mean?
I have a question,
Yeah.
but it's more like general. What does it mean when compression steel yields?
Do you know here this term? This term can tell you what is the force in compression steel. That's right. This force equal area steel time F yield. You assume yielding here. But if this not happen, this term must be F steel. I don't know what is this value. It will be more complicated because yielding not happen. Your stress in this steel reinforcement not known. So I cannot assume it equal 60. I need to put another value here if this condition happens.
Are you asking like what does it look like when it yields?
Yeah, I mean
What?
that also.
Yeah. I don't-
Like what is happening?
What will happen? You still here. In the bottom reinforcement, you reach this point. But in the compression reinforcement, you didn't reach this point. You still, your stress is within the elastic limit.
What about in a real world scenario? What does it look like? What? how-
Nothing. It's only design.
Oh.
You are designing. You will not see what will happen inside the concrete, yielding or not yielding.
Because as soon as it happens,
But like if you have
It
steel
don't matter.
yielding, that's what
If you have steel reached yielding and beyond the yielding point, you can expect some cracks in your member, some cracks in the beam. If you exceed the yielding stream, so you can expect more cracks.
never yield.
no pass.
It should be smaller.
Because it's, formation.
No, because yield is up there. So if it doesn't yield, then
In the real life, we don't like compressive reinforcement. We don't like doubly double reinforced section. We don't like this kind. But sometimes you have limited depth of concrete, so we need to compensate this limited or shorter in concrete by compression reinforcement. Like this classroom, it's not easy for cinema. People are watching. We need clear height. Maybe for bridges also, you have track, and your track will need to clearance. So we have limited depth of your concrete beam. So we need more. We cannot. So we need to add additional reinforcement and compression. Yeah, that's enough for today. If we yeah, what will happen if the compression steel not yielded? What will happen? Your equation will be more complicated a little bit from the quadratic order, and we need to solve for C. We will continue next time.